Hi, my name's Alex Haddock. I'm a chief technologist here in the UK, focusing on compute. And today I'm here to talk about HPE ProLiant Gen12, our latest servers, specifically on performance and efficiency. Now actually performance and generations are typically linked. What tends to cause us to go to a new server generation is a change in a CPU socket. And that is exactly what we've had in Gen 12 with respect to Intel. We have a new CPU socket, and that is running Intel's Xeon 6 processor. That is what has driven that change. So Xeon 6. Now within Xeon 6, it's quite important to be aware there's two different cores. Never has infrastructure been so important in this age of AI. There are two very different core types. E cores and P cores. Efficiency cores and performance cores. Makes it easier to think about. So those efficiency cores, they're not the highest performance. They are very high density. They are designed very much to give you many cores, virtualized workloads and the like. Not the highest performance, but very high energy efficiency. If you look at the P cores, well, they are the latest generation in the iterations we've had over the years, and those are designed to be very quick. Now, if we look at those two ranges, the code name for the E cores is Sierra Forest, and for the P cores, it is Granite Rapids. Now in the ProLiant Gen 12 range, unlike in our HPC range, we use the SP processor. So if you want the AP processor, the one with 12 memory channels and higher TDPs, that is again not the topic for today, but we do support that in our ProLiant XD ranges. If we start to look at the breakdown of these processors, then we could take an example processor in the 6070 80E. Very conveniently for Intel and us, they have actually made it very clear this is an E core by putting an E at the end. That is actually 144 cores of these efficiency cores. Conversely, if you look at the SP processor, you might have a 6787P performance core, which is 86 cores. Now, typically these 6780Es and the other E-core variants will be seen in service providers, people building their own clouds, in effect. The P-cores we tend to see in enterprise. So for the majority of users, and the majority of use cases, this will be the most common processor. It's logically the direct successor to what you may have been buying in HPE ProLiant Gen 11 Intel models, for instance. I'll just write a C on here just to make it clear these are cores as well. So that's covered the Intel side of the story, but what about AMD? So AMD is a bit of a different situation. There's been no change in CPU socket. So they just effectively have a new processor. And that is actually slot upgradable Turin, also known as Zen 5 or Zen 5C as well for the smaller core. Those processors are already in our Gen 11 servers. So DL3X5 to denote 325, 345 and 385. So if we've already got the latest AMD processors in Gen 11, why would we need to go to a Gen 12? Well, actually, we've taken a decision in the single socket systems for a few reasons. One, we have ILO 7, which is a topic of some other videos in this series. But then also, we start to have some situations where we want to accentuate those one socket servers by actually doing two things. One, and this is a critical one for me in some of my customer pursuits, is that we want to increase the memory slot allowance. So in this we now have times 2 slots, which equals 24 DIMMs. This suddenly means we can get 3 terabytes of RAM with cost-effective 128 gig DIMMs in just a single socket server, which is almost crazy. Actually, we can go to 6 terabytes, but the 256 gig DIMMs are still quite cost prohibitive. Plus, we have also gone to the max TDP on these new single socket servers, up from 400 watts in Gen 11 to 500 watts for these single sockets. So we can support the latest AMD 192 cores, which are the Zen 5C, or the 128 Zen 5. Now there's not a huge amount of difference between a Zen 5 and a Zen 5C, unlike the E cores and P cores in the Intel range. Effectively, they all have the same functionality, just higher clock speeds and more cache for the 128 core. So in summary, what that allows us to do with, say, a DL345 is have a massive 128 full fat cores and 3 terabytes of RAM in a single socket server. That has massive benefits for power consumption. It has massive benefits for software licensing if you're licensed per socket, such as on our HPE Morpheus product range. Now, should you be an Intel customer or wishing to stay with Intel, then the good thing is now Intel has a very strong single socket story themselves, unlike in the previous generations. So we have the DL, cunningly named 340 Gen 12. So with their full fat cores, we can be looking at 86C and 2 terabytes with those cost-efficient 128 gig DIMMs. Now I've just talked around the latest processor and memory enhancements in HPE ProLiant Gen 12 that lead to a huge amount of performance. But to achieve that performance, we absolutely need to keep things cool. And that is why in HPE Gen 12, all the DL servers, the density servers, will have the option for CPU DLC. Now that is direct liquid cooling. This is becoming more and more of a necessity in the data center for various reasons, but one is performance, then we have density, and then finally efficiency. Performance becomes more and more critical. You've acquired some high value servers. You want to make the most of them. So therefore we want to make sure that the server processors are running at their optimal. To do that, we need to keep them cool. You may have limited space. Therefore, how do we get the density in systems that have 500 watt processors, let alone graphics accelerators that might be 600 watts each? And of course, for efficiency, you want to be able to make sure that you can have the lowest run costs and also contribute to having the lowest possible carbon footprint. So we start to look at the impacts of cooling in the data center. If we take the server cooling, so this is the power to cool a server, not to run it, then relatively, this one on the left is a 1U air. So a DL360, for instance. You can actually make some really good savings, and we're starting to see this more and more often, by actually going to a 2U air server. So this is a mitigation in effect. This can save you significant cooling power, particularly because it's the fans are more efficient. And then, as I discussed earlier, if you go to a single processor, you can save even more power. But finally, then we start to see DLC, direct liquid cooling. Now you might be wondering why that's actually not a huge power difference between the 2U and the DLC. Well, firstly, the DLC lets you get the density. It also, however, has a massive impact on data center cooling. So this is the actual air conditioning into the data center. This is where you can see significant savings. So whilst it remains common for the other technologies, as soon as you go to direct liquid cooling, you can make a significant saving. And this is the reason why we've added direct liquid cooling to all Intel and AMD DL servers in Gen 12, whereas in Gen 11, only a few of them had it. So in summary, we have the latest CPU technology from both Intel and AMD in our HPE ProLiant Gen 12 servers, along with the supporting infrastructure designs and memory capacities to ensure the best value is taken from them. The net business value of this is, for example, that we could take a 24-to-1 consolidation from Gen 8 with significant data center space, cooling and power savings as well, or even with the very recent Gen 10s, a 5-to-1 or a 6-to-1 depending on the generation of Gen 10 consolidation. So as you can see, there's significant business value in moving to HPE ProLiant Gen 12. Thank you for listening. If you'd like to know more, please see the link below where you can see some more videos in this series and further information on HPE ProLiant. Thank you.